Hello viewers of mine, this is a What the Physics video. This one is on Excel graphing 101. Now, we call it Excel graphing. Notice there's actually a number of different flavors of Excel, and this was originally done by a buddy of mine, Greg Ryder, and he did it for Excel 2013. And then since then I've added on to it for Excel 7 and Office 365. And then finally, I'm adding on the Google Sheets version. So all sorts of different flavors. You find the one that works for you. We're going to focus on Excel, not on Excel today. We're going to focus on Google Sheets. So here we go. We've got this data table. This comes from a little very basic lab activity. Notice you can see the first column, which is going to be on the x-axis or the horizontal axis. We're not going to really call it the x-axis because, as you'll see, we'll rename it. Anyhow, extension, and then weight is going to be on the vertical axis. So the first column is always the horizontal, and the second column is the vertical. Now, what's going on in this lab that we never saw happen? It's essentially you've got a spring hanging vertically, and you add weights to it, adding more and more weights, and you are measuring how much this spring extends. And this is essentially a Hooke's Law lab, but we can come back to that. And I want to talk about independent and dependent variables too while we're at it. But let's go ahead and kind of jump right in. So get out your handy Google spreadsheet. I've already entered the data just to make it a little bit easier. There's only 5 data points in here. We got and I notice I put extension and weight. That's on the first row. So I've highlighted this. I'll do this again. So I hold down on the mouse button and I just spread it across there. So it's highlighted. And now I'm going to insert. And I'm going to insert a chart. Now, I think it'd be better if Sheets called it insert a graph. Don't know why they didn't. They like to call it a chart. And boom, this is what shows up. And if you look at it, actually this is a great chart because it has a whole bunch of stuff filled in. Be even greater if it were called a graph. Anywho, it's got a title. And notice it's a Y versus X title from the Y axis. Remember, it's now called weight axis in newtons. And the extension is on this one here, extension axis in meters. Okay, so that is all set up for us. That's great. And we've got our data points. We will probably want to adjust the range in here. Oh, I'm getting a little bit ahead of myself. So it's set up as a scatter plot. In case yours is not set up as a scatter plot, what you can do is easily change that. So we are currently in the setup part of the chart editor. That's what automatically showed up. You just scroll to the top. And if it doesn't show up as a scatter plot, you can clickety-click right here and go through all these different ones until you find the scatter plot option. There we go. Oh, there it is. Just passed by it. Okay, scatter plot, yay. If it came up as a pie chart or a bar graph or who knows what, you can just change it there. Boom. But we don't need to change it, so we'll just move on. All right, go to customize, and usually we are going to want to start things from the 0, 0. So we can go into, let's see, well, chart and axis titles, they're already set up for us. But if they weren't, we could put all these in. Here's the title and such. And then if we want to adjust specifically one axis at a time, I'm in the horizontal axis right now. And see, horizontal axis. I can change up a number of things in here. That's cool. But once again, I don't really need to change anything in here other than the minimum and the maximum values. So I'm going to put in the minimum value as 0. Okay. And the maximum value, it looks like it's got all 5 data points on there. So that's great. Okay. So I did that to the horizontal. I can also do it to the vertical. Although it does look like it starts at 0, but I'll just go ahead and put it in. Minimum value is 0. If for some reason this were cut off, I could adjust the maximum value here as well. Okay, but now it's clearly showing this, and the origin, the 0, 0 point. Great. Okay, let's go ahead and close that up. Now we see all these different things. So that's really all you have to do for the horizontal and vertical axes. And like I said, if you need to change the title or something, but we didn't have to. It was all done for us because Google Sheets is actually really cool. Now we're going to spend some time in series. So go into series. I think I would have labeled it like analyze, but once again, this is called Sheets, not Fair's work. So scroll on down and we want to make a trend line. And look at that trend line. It's lovely. It's a nice straight line. Probably a y equals mx plus b in just a moment. We'll see. And in fact, let's see what it is. Change this label. So we're going to change label. Currently, there is no label. We'll put on use equation. They're like, oh, look at that. That's great. It is a y equals mx plus b, right? Yes, it is, but should it be? And you say, what are you talking about? Well, it was preset to do linear. Should we have done linear? Well, in this case, it is a linear relationship, but I'm not absolutely sure that all my graphs will always be linear. So what I can do is I can show r squared, and my r squared, don't want to get into what that really means, other than we want the r squared value as close to 1.00 as possible. So you can see 0.994, that's really awesome. So this is going to be a nice linear relationship. However, it won't always be. So how do we know if it's going to be a nice linear relationship? Well, we try other fits. Specifically, we go back up here to the type of trend line, and we change it from linear to a power series. Now, as you can see, it didn't really change much of anything here, but it did change this equation just a tad up here. Now we say, okay, yeah, I guess it did. Now it's got this weird, oh no, what is this? 18.2x to the 0.981. What? Why would you possibly want to do that? That makes it even more complicated. Ah, yes, it does, but it will be for good reason because we're going to be looking at this x exponent, okay? The exponent that goes along with the x here is 0.981. 0.981, that is super duper close to 1. And that's a good sign. That means anytime your exponent for your variable here, remember that's going to be this guy here, anytime that is 1 or really close to it, that means we have a linear graph that we're working with. Okay? It won't always be equal to 1 or something really close to it. It could be equal to 2. In that case, you'd see it's a squared relationship. It could equal, the exponent could equal 0.5. That means it's a square root relationship. And then we can also have inverse relationships. But right now, it's a nice, easy fit. But still, I'm going to go through the process of changing things up. This is what you need to do every time you're doing this. This is for my honors. Every time we're doing this, we're going to go through this process. So I'm going to go from, actually, I'm going to click on this. Maybe triple click so it's highlighting these values, and I'm going to copy it. So Control C for a copy. Okay, and then it kind of got me out of the series section, so I'm going to go back to series. Oh, popped me into legend. How silly. Go back into series. Here we are. Here we are. Okay, so power series, right? Right. Now, instead of use equation, I'm going to change this to custom. Oh, and then this is where I get to fill in. Now you say, well, why would you do that? Well, because as it wasn't giving us a whole lot of information in terms of what the graph was actually doing. So I'll paste that in, and I'm going to change this. I'm going to have, instead of like labeling y and x, I'm going to say weight in newtons equals, oops, I jumped to the end here. And then just to make it easier for me, I'm going to put in like parentheses, 18.2. And I'll come back to those units in just a tick. And then another parentheses. I'm going to change out the x because remember, I don't have an x-axis anymore. I have an extension axis. He's like, ooh, extension. Okay, so extension raised to the power of 0.981. Okay. So we can put parentheses around that. And, oh, before I move on, the units on this. As I kind of implied, this is linear, and hopefully we can see that. But, so we recognize this number here is just going to be the slope. So what would the slope units be? Well, rise over run, that's going to be newtons over meters. So I'm going to pop those into 18.2 newtons divided by meters. Okay, okay, good stuff. All right, so this is my graph all set up in the power version. Okay, remember the trend line is the power series. Now I'm going to do my analysis of that and see what I need to do. So now we're going to talk about how to linearize the curved data. So in this case, as I said, it's already a plain Jane. The exponent is 1. Will it always be that? No, it can have all sorts of curves to it. We've got the overachiever, we've got the underachiever, and we've got the nonconformist. And what you do in order to linearize is totally dependent on what shape you got. Whether you've got to square the x-axis in order to make the x's kind of catch up, that's what you'd be doing right here. Whether you want to square root the x-axis, that's what you can do here, or whether you want to invert the x-axis values, okay? Now, in this case, because we have, let me get this out of the way here, move you over here. In this case, because the exponent is 1, or essentially 1, we don't need to worry about doing anything. It's already a linear relationship. But I'm going to leave this here to demonstrate that I did go through the process to verify that. He's like, oh, okay, great. Now what? Well, if we did have to do something to linearize it, what I would do is I would make my new list of variables down here, or list of data from the variables right here, and I would change up whatever I need to do. Like I said, I'm usually changing the horizontal axis information. So I could square or square root or invert, depending on what type of shape it was. In this case, as I said, it's linear. Now, I'm going to do the exact same thing I did before. Let me scooch this up a little bit so we have plenty of space. Okay, and we're going to highlight these. So this is all highlighted, and then once again, we're going to insert a chart. And you say, oh, doesn't this look familiar? Why, yes. Yes, it does. So I'll go through the same process again. Remember, we had to adjust the axes. In this case, once again, I don't need to do anything in setup because it's already a scatter plot. But I go into customize, and I can adjust the horizontal and vertical axes to make sure that they are starting from 0. Okay, so, oops, look at that. I clicked on the wrong spot. Oopsies. Oh no, what do I do? Unclick. It's pretty straightforward. All right, so that was the horizontal axis. And then what about the vertical axis? Well, I don't really need to put in a 0 because it's already has the minimum as 0. I'll make sure not to click up here by accident again. Okay, and that's all set now too. How lovely. Okay, so adjusting the axes is all set. Now I go to where I need to spend most of my time is in series. And as before, we do a trend line. Now, we already know it's going to be a nice linear relationship because we demonstrated that up here because we had the exponent really, really close to 1. So I can just keep it. Keep my trend line, I shouldn't say it, keep the trend line as linear. Okay, as long as I've linearized this properly, whether the first graph is an overachiever, an underachiever, a nonconformist, or some weird combination of those, and then I linearize it down here, I should get a nice straight line graph. So that means I keep it as linear. I do need to show the equation. Okay, 19.1, we remember this from before. It's a y equals mx plus b graph. However, I need to change it from y to weight, and then from x to extension. So triple click, copy. It just makes it easier. I mean, I could just write it down on a sheet of paper and then put it in, but that just makes it a little bit easier. Get out of legend, go back into series, and then I go from use equation to custom. Custom is the one that I can change up myself. And trendline for weight, that's a relatively useless bit of information, so I will just totally get rid of that. Paste in. Now it's a y equals mx plus b. But remember, I changed y into weight. Weight in newtons equals, the m is the 19.1, that's the slope. Remember, the units for slope here, rise over the run, newtons over meters. Newtons per meter, close parenthesis. Now we've got that x in there. We're going to take out the x and put in what x was replaced by, which is extension. And we can put in meters there. Okay. And then here is the b. That's the y-intercept. We don't need to change that. That number is fine. The only thing we need to do is add in the units to this. Where did you go, cursor? There we go. All right, so as you can see, it's 0.0112, and then it's the units of the y-axis, so that'd be newtons. Okay, and then finally show the r squared, and it's got all of it there. Okay, so scoot this over. You can even add in some extra zeros, so there's a little bit more space. You can easily see that there, right? Right. Okay, so we've got this all set up. So what we've done, quick summary. We take the data, enter it in here. This is the X, and then this is the Y. We leave those labels on top there. Putting them there means I will automatically get my axes labeled. Scooch this one down a little bit. There we go. And then that also labels the title. Okay, and then we went into insert, and then we clicked on chart, and it popped up as a scatter plot. If it didn't pop up as a scatter plot, we could have changed that. Notice my chart editor just went away. That's because I clicked off of the chart. So that way I could type in here like, physics is delicious. Okay, just because. Now if I want to get that back, what do? I just double click on here. Okay, all right, and then we can adjust the axes. Let's shrink this up. We can adjust if we need to change the labels, we can click in here. If we need to adjust the axes range, we can click on the horizontal and vertical. And then we'll spend most of our time though in series. Series is where we turn on the trend line, and in the first case, specifically for the honors or the advanced academic folks, I would go ahead and change this to a power series. And then the power series comes up as an exponent here, and as long as that's really close to 1, you're all set. You don't have to change the numbers to linearize. If the exponent is something different, like squared or negative or like 0.5 or something, then you got to do something to linearize. Anywho, you go into custom, and you had copied and pasted the equation in, so you can add in the units and change up the labels from y and x to weight and extension. And then you go through the whole process again. You do whatever you need to do to linearize this first column, square it, square root it, invert it, maybe a combination of those. Pop that in here, and then you highlight and insert the chart. Okay, and then up this pops, and then you change, you go through the process again. Okay. Oh, and one last thing. So I had mentioned about what this experiment was. It was, we were adding on weights to a spring to stretch it out. Well, the amount of stretch was dependent upon the weight added. So in this case, the weight would have been the independent variable. So you say, well, fair, why didn't the weight go on the x-axis and extension go on the y, because that's the dependent variable? Because, and as I mentioned, this is Hooke's law. The experiment is called Hooke's law because it's named after Robert Hooke. He was the first one to find the relationship between the stretch of an elastic object, like a spring, and the force added to it. It turns out if you double the force, you're going to double the stretch. It's a great relationship to realize. Anyhow, he wanted it set up as in you would be solving for the weight or the force applied. So even though that was technically the independent variable, he set it up so we get a force is equal to some constant, that's the spring coefficient, times the stretch length, and that is Hooke's law. Okay. So we don't always put the independent on the x. It really just kind of depends on what relationship we're looking for, because that's physics. Physics. Delicious.